Slope and steepness of a line. The slope of a line, m, is the rate of change of its y values with respect to its x values. The terms slope and rate of change can be used interchangeably. Slope is calculated by dividing the change in the values of the y-coordinates of any 2 points by the change in the values of the x-coordinates of those same points. Since the Greek letter delta, which is a little triangle, is used to represent change in each variable, this results in this equation for the slope of a line. M is the change in y over the change in x, which is y2 minus y1 divided by x2 minus x1, where x1, y1 is 1 point and x2, y2 is the second point, 2 different coordinates of any 2 points that are on that line. Slope, or rate of change, can be thought of as rise over run. The change in y is the rise. We go up, right? We rise. And then we go across. We run across. The change in x is the run. So the slope would be change in y over change in x, which is rise over run. Slopes can be positive, negative, 0, or undefined, as seen in the following slides. Using the points 2, 4, and 8, 11, we can see that the y-coordinates go from 4 to 11, which means we go up 7 units. In the x-dimension, we go from 2 to 8, which means we run across 6 units. Slope is change in y over change in x, so that is 7 over 6. The positive slope is seen in the rise of the line. Using the points negative 3, 6, and 9, negative 4, we can calculate the slope. Y changes from 6 to negative 4, which means we go down 10 units. X changes from negative 3 to 9, which means we run across 12 units. Negative 10 over 12 gives us a slope of negative 5, 6. The negative slope is seen in the fall of the line. The line is falling from left to right. All right, here we're using 2 points on the line 2, 8 and 10, 8. You can see the y value, the y-coordinate, is the same for both. So therefore, there is no change in y. So even though there is a change in x of 8 units, we have 0 in the numerator. 0 over 8 is 0. 0's slope is seen as a line being horizontal. Here we're going to use the points negative 6, 2 and negative 6, 7. We do have a rise of 5 units. However, the x-coordinates are the same, which means there's no run. Rise over run is slope. If the run is 0, we can't divide by 0. Therefore, the slope is undefined. The slope is undefined due to the division by 0. The undefined slope is represented by a vertical line. Any points on a line can be used to calculate its slope because the slope of a line is constant. The change in y and the change in x may be different when found with other points, but the ratio will be the same. The slope between any 2 points on a line is the same, as shown here. We have negative 7 and negative 7. Negative 7, negative 7 is our first point. 2, 2 is our second point. If we do rise over run, we get a slope of 1. Here we have 4, 4 and 9, 9. If we do rise over run, we once again get a slope of 1. If a graph is not given, the slope or rate of change of a line that passes through 2 points can still be calculated. Let's say a line passes through negative 5, 4 and 5, 0. Its slope is calculated by this process. First, identify negative 5, 4 as x1, y1 and 5, 0 as x2, y2. Second, substitute the numbers into the slope formula for their assigned variables. So, change in y is y2 minus y1. y2 minus y1. So that would be 0 minus 4 in the numerator, giving us negative 4. Change in x is x2 minus x1. 5 minus negative 5. Those negative signs do cancel, giving us 10 in the denominator. If we simplify, we see the slope is negative 2/5. Slope formula can be used to find the constant rate of change in a real-world problem. The graph here represents a car moving at a constant speed on a highway. The car passed mile marker 60 at 1 hour and mile marker 180 at 3 hours. Take the slope of the line. 180 minus 60 in the numerator gives us 120. 3 minus 1 in the denominator gives us 2. 120 over 2 is 60. The slope of the line is 60. Since the y values represent distance in miles and the x values represent time in hours, the slope results in miles per hour. The car speed is then 60 miles per hour. Slope, or rate of change, is the rate of change of y with respect to x. It can be positive, negative, 0, or undefined. Steepness is the absolute value of the slope. It is always positive. For lines with a positive slope, their steepness and slope are the same. For lines with a negative slope, the steepness is different than the slope since it will be positive. Calculate the slope of the line that passes through 6, 2 and negative 5, 4. The first step is to identify the first point as x1, y1 and the second point as x2, y2. It doesn't matter which point is x1, y1 and which one is x2, y2. All right, so we make the first point 6, 2, x1, y1, and this one, negative 5, 4, is x2, y2. Change in y is y2 minus y1, 4 minus 2. 4 minus 2 gives us 2. All right, x2 minus x1 is negative 5 minus 6, which is negative 11. Therefore, our slope is negative 2/11. If a car moving at a constant speed passes mile marker 100 in 2 hours and mile marker 200 in 4 hours, then how many miles per hour is the car traveling? Let's identify 2, 100 as our first point, x1, y1, and 4, 200 as our second point, x2, y2. All right, where y represents the distance that we're traveling, so distance is on the y-axis and time is on the x-axis. Okay, so we get a line like this. I'm just going to show you. We get about 2 and 4. So at mile marker 2, we are at 100 miles, and at mile marker, or at time 4, we are at 200, like that. So this is a graph of this situation, but we don't need a graph, but it's nice to visualize. All right, so then we have change in y over change in x. 200 minus 100 divided by 4 minus 2 gives us a slope of 50, and slope is rise over run. So rise is in miles, run is in hours. So therefore, the speed is 50 miles per hour. Line A has a slope of 3, and line B has a slope of negative 5. Which has a larger slope? Which is steeper? Line A has a larger slope because 3 is a bigger number than negative 5. However, line B is steeper than line A since when we take the absolute values of the slopes, we see that 5 is bigger than 3. Compare line A and line B on this graph. Which has a larger slope? Which is steeper? Line A has the larger slope because it's positive, but to be more specific, it's 2/9, whereas the slope of the blue line, the B line, is negative 1. Since 2/9 is a bigger number than negative 1, A has a larger slope. However, line B is steeper than line A because when you take the absolute values of their slopes, you see that 1 is bigger than 2/9. Order lines A, B, and C from largest to smallest with respect to slope, rate of change, and steepness. All right, so the one with the greatest slope is A, it's positive slope. B has 0 slope, so that's the middle one. And then C has a negative slope, so that's the lowest one. Rate of change is the same as slope. This was like a trick question. Therefore, the answer is the same as for part 1. However, steepness-wise, C is the steepest, then A, then B, because you can use the absolute values of the slopes.